So up to this point, we've been talking about quadratic equations, and they've been in standard form. Remember, y equals ax squared plus bx plus c. And today we're going to take a look at just another form of a quadratic equation called the vertex form. And the vertex form is helpful for us to quickly be able to identify the vertex and also the axis of symmetry if we're looking for just a quick sketch of our quadratic function. So the vertex form is y equals a times x minus h squared plus k, where h comma k is the vertex, and therefore x equals h would be your axis of symmetry. So when we take a look at a quadratic equation that's in standard form, we're going to start by using that process of completing the square to get it into vertex form. So let's just take a look at number 1 here. So in number 1, we want to write the quadratic function from standard form into vertex form. So remember that before, when we were completing the square, the first step for us was to set the equation not equal to 0, but equal to the constant. So similar to that, in this case, we're going to move the constant to the other side, but it will be with the other variable of y. So we're going to start by subtracting 1 from both sides so that we've moved that constant over to the other side of the equation with y. And we're left with x squared minus 8x, which will allow us to complete the square on x squared minus 8x to make it a perfect square trinomial. So just like we did when we were completing the square, we want to take that b value, 8 divided by 2, and square it to get 16. And so it is a positive 16 that will add to both sides of the equation so that we have x squared minus 8x plus 16 as that perfect square trinomial. So y minus 1 plus that value, which we found was 16, and x squared minus 8x plus that same value, which we found to be 16. And remember, we found that value so that we could write x squared minus 8x plus 16 as a binomial squared. Okay? That binomial is x minus 4. Remember, factors of 16 that add to negative 8 are negative 4 and negative 4. And then over here we'll have y plus 15. And then lastly, we just need to isolate y. So we're going to subtract that 15 to the other side of the equation. And we have y equals x minus 4 squared minus 15. And so you'll notice that finding h and k, your vertex, is going to be 4, negative 15. Let's move down to number 2. Y equals x squared plus 14x minus 2. So again, we start with that same process. We're going to move the constant to the other side. So we have y minus 2 equals x squared plus 14x. And then we're going to find that value that we're going to add to both sides. That makes x squared plus 14x plus something a perfect square trinomial. So remember, half of b squared. So 14 divided by 2 is 7. 7 squared is 49. So it is 49 that we are going to add to both sides of the equation, giving us, oops, hold on one second here. Let's erase that. Not y equals, but y plus 47 equals, and we're looking for the factors of 49 that add to 14, and they should be the same, 7 and 7. So x plus 7 squared is our perfect square trinomial. Now we're going to subtract that constant back over to the other side so that we've isolated the y. And so we have y equals x plus 7 squared minus 47. And again, you should easily be able to identify that your vertex is -7, -47. Okay, remember that in the formula, it's x minus h squared plus k. So h, when it is a positive, must be a negative value. Okay, go ahead and try 3. So hopefully you found that the vertex in 3 is -6, -38. Okay, let's take a look at that. So that starts by adding 2 to both sides, giving us y plus 2 equals x squared plus 12x. We're looking for the value to add, which is going to be half of b squared. So 12 divided by 2 is 6. 6 squared is 36. So y plus 2 plus 36 equals x squared plus 12x plus 36. Okay. So remember, our perfect square trinomial, you should have had x plus 6. And over here, 2 and 36 combine to give me 38, which I'm going to subtract to isolate the y. And so in vertex form, y equals x plus 6 squared minus 38. So h is -6 and k is -38. We'll go ahead and do number 4 as a warm-up in class tomorrow.